Hey everyone, thanks for making it to the next to last session. Is that right? Before you have to take trains and get back to your homes. My name is Jimmy. Today we'll be talking about composite UIs, which I think of the last mile when it comes to microservices. You can find me on Twitter at @jbogard, and this presentation and pretty much everything I do is on my github.com/jbogard. And I also blog at jimmybogard.com. I also have an older blog on Los Techies, so if you search for Los Techies, you'll find a lot of my old content there. I've got hundreds of posts over there that are just languishing on an old WordPress site that I don't know how to get off there, so a lot of stuff over there too. I do a lot of open source stuff, so you probably know me from Automapper, but I also have another few for other projects that I like. Mediator's one, and the other one is HTML tags. So that's a little bit about me. Let's talk, before we get too far into composite UIs, I want to take a little bit of time to cover a few important points about microservices. Now, microservices is a little bit interesting to me in that it seems like it's an interesting movement in which it takes older concepts, puts new names on them, and then takes credit for those old concepts. So I want to really try to ground on some of these ideas that have been around for sometimes decades. First of all, microservices is not a specific technology or stack. So it's not Azure, it's not AWS, it's not Docker, Kubernetes, it's not domain-driven design, it's not REST, it's not any of those things. And in fact, if someone's trying to tell you that you have to do microservices with a specific technology or stack, they're probably trying to sell you something. So be very wary of that. That was really what got SOA in the end, was the vendors taking over all these different pieces. So this talk will try to be as vendor agnostic and talk about fundamental technology choices and not try to talk about specific products that can help you out. So what is a microservice? Kind of depends on who you ask, unfortunately. There's a lot of definitions out there. But I try to find, because it's got micro in the name, the smallest and most concise definition of microservices. And this came from the Microservices book. And microservices in that book was defined as it's small and focused on doing one thing well, and it's autonomous. And that's it. That's your two lines about what a microservice can mean. Now, behind there, of course, there is a lot of arguments about what those terms can mean. So, for example, if you're building microservices in something like Go or Rust, small can mean really, really small. But if you're using something like Java, then maybe your services are half XML configuration, and so they're very, very large. So there's no real consensus about what small means, but it's small enough. And of course, the one thing, what does that mean? Like one if statement, one piece of information I show on the screen? That can mean a lot of different things as well. But for me personally, what a microservice represents is the smallest, most focused thing that could still be autonomous. And autonomous is something we're going to be talking about a lot during this talk, because composite UIs are the thing that throws a wrench into the entire autonomy principle. So autonomy means a lot of things. First of all, it means we have an independent ownership, availability, and delivery of our service. So typically this is a full stack team, all the way from the product owners and business analysts all the way to testers and deployment. One team responsible for the entire delivery of this one individual service. They're also responsible for its uptime, so there's not a separate DevOps team. Do anyone here have a DevOps team? You're doing it wrong. That's DevOps wrong. I'm sorry. DevOps is supposed to be ingrained inside your teams. It's about a delivery pipeline, not about a specific team. This microservice is supposed to be managing the information inside that service as well as access to this service. And this is where those big brokers in the SOA land really screw things up, because that's where a lot of data and ownership started to seep into, were these big central applications and big frameworks. So a microservice is intended to encapsulate all of the information and control access to that information as well. Next, it should manage any failures associated with any sort of request. So I'm not letting it be someone else's problem. It is my problem. I'm supposed to have the pager or Apple Watch that I'm getting buzzed whenever something goes down. And finally, it needs to maintain contracts talking to other potential services. So with all these together, all this idea of autonomy, we can start to paint a picture of what it would look like in an ideal world, building a system full of microservices. In this ideal world, we have individual services that have their own separate autonomy boundaries, doing their own individual thing. They each have their own applications. They each have their own databases. I might have a sales application on MVC core. I might have a shipping application on old MVC. We have the orders people over there that I guess are like hipster folks, so they're building an Electron app on top of MongoDB. And of course, there's the poor ERP people, still on an IBM AS400 mainframe. They're probably counting down the days till they're retiring. Maybe they're getting a pension or something. I don't know. And I don't know what the user interface is for those people, but it's probably green. I would think so. So with each individual set of services here, you can imagine that each set of the people using these applications only really uses those individual applications and nothing else. You may have like a CIO or CEO that needs information from all those sources and, of course, like one gigantic Excel spreadsheet to run the company. But for the most part, individuals that use those applications don't really cross any service boundaries. They use their applications for their daily work, and they go on with their day. Except for this guy over here, the ERP person is probably playing a lot of Pokemon or something like that. I don't know, because it takes a long time for results to come back from that old mainframe over there. Now, there are occasions where these different organizations do have to talk to each other. They have to coordinate some activities to actually run the business. But for these backend services, autonomy can be pretty easy to do because the users are constrained within each individual application. And in fact, when we're looking at how to draw the service boundaries in the first place, it's also, I wouldn't say trivial, but it can most part just look at the organizational boundaries of the company and then design your service boundaries around them. This is what's known as Conway's Law. It says any organization that designs a system defined broadly will produce a design whose structure is a copy of that organization's communication structure. So basically, build the apps and services around the organization structure of your company, and as long as your organization isn't organized ridiculously, then it should come out to be okay in the end. There are some downsides to this, of course. If your organization is not structured well or not structured well for the future, you may have to build services for the organization you want, not the organization you have, or you may have to reorg to get to the organization you want and then build applications according to that. But for the most part, services belong to specific organizations inside the company. And in fact, if you looked at these boundaries and rewound time 100, 150 years, we may find that the exact same service boundaries we drove for different organizations inside a company 100 years ago are the exact same things they'd have today. They'd be responsible for the same sort of things. They'd have the same sort of activities and tasks they do on a daily basis. The only thing that's a little bit different is maybe today everything is a little bit more sped up, so I can communicate much more quickly. But otherwise, if I'm looking at how to connect these services just one-to-one, I'm going to be using the exact same communication styles and structures I would use from 100 years ago. The same exact constraints I would have 100 years ago are still the same constraints I have today. I can have blocking communication, I can have out-of-band communication. But for the most part, even though latency has gone much down, as long as I'm not making silly choices about those arrows they have back there, everything should just work okay. We can go pull out those old integration books that tell us how to connect different pieces together and use standard protocols. I can use REST or HTTP or maybe GraphQL, because that's a thing now. And I can use different messaging protocols, and as long as I choose really forward-thinking protocols and communication styles, I shouldn't really have a problem connecting those backend services together. But we're not here to talk about that. We're not here to talk about those backend systems that are really easy to do, and we just do some like integration services to connect things up. We're here to talk about composite UIs. Now in that picture, I didn't have all the services. There was no real composite UI. I may have some communication between different services, but there's nothing that actually represents a single view into the company. And that was a problem though, because if I look at those different services I had before, none of them actually generated any revenue for the business. There's nothing that the user comes in and says, I want to buy something. I need all these services. Can you have a coherent, singular experience for me? So let's suppose I rewind time again, back 100 years, and see what would a composite UI look like before there were any computers involved. So in a composite UI circa 1900 or so, and these did exist, I might see something like this. Does anyone know what this is? This is the very first department store that existed in the world. This is Selfridges in London. Selfridges really pioneered a lot of the concepts behind department stores. The idea behind sales, to have a sale to like 10% off for some holiday. That's something that was really pioneered by Selfridges. And before these kind of department stores, you would typically go to a specific person who made that thing to buy that thing. So you didn't have to worry about any sort of composition. You went to the hat maker to get a hat. You went to the shoemaker to get a shoe. And it was that single stream delivery that you went to the person that made the thing to get the thing. This really threw all those concepts out the window and said, right, why don't we have one single customer experience where someone can come in and buy a wide variety of things and have that nice, seamless experience where they don't have to worry about, oh, this kind of thing versus that kind of thing, and they just go in and peruse many items and buy whatever they want. So the composite UI of this kind of, I think this is what, 1940s, looking at those cars. There's probably, probably everyone's wearing a hat at this point. They look very hot in their suits as well. If I looked at what that composite UI was back then, it would be one of the departments inside a department store. This one, for example, I think is the perfume department. You can tell it's also old because one of the things that they really pioneered as well is having people spray the perfume in your face to make you want some or to run away, I don't know. And there's none of those people here, but they should be. And what this provides is, again, a single experience for a consumer who can come in and consume all of the different back-end services that a department store will provide. Shipping, inventory, warehousing, everything comes together into this one single interface where a user comes in and the entire experience is designed to sell them something. So if we look at the kind of challenges it would take to build this kind of experience for a customer, well, they don't have to know any of the back-end services and departments behind the scenes. A lot of the challenges they would face with this kind of experience are very similar to the ones we would have with the kind of experiences we're trying to build today. So if I can figure out how are they building those compositional services before computers, I might be able to use those same sort of techniques to build those kind of services today. And I think of this problem as the last mile problem. This is, by the way, this is a term, right, that everyone uses in places where they don't use miles. It's not like the last kilometer problem here, I don't think. I verified this with a few, like everyone else, I guess, besides the United States, uses kilometers except for us. And the idea here is that this came from telecommunications. It's super easy to build these really big backbones of the internet and telecommunications. So phone, internet, whatever it might have you, it's really easy to build those really big pipes that can go from city to city or country to country. But the really difficult part comes in taking those final services and delivering them to the final end user. And that final end user is the most important part. Without someone to answer a phone, there's no phone network. Without someone to browse Reddit, there's no internet. Without these final users of these services, there's no point in having the service in the first place. The same thing with our composite UIs. The composite UIs are almost always built to handle that final user who's going to be purchasing something or in some way delivering the revenue stream to my company. So in this original set of services, where I have these made-up services like sales, shipping, orders, and those poor ERP folks, although they may have upgraded now, maybe they're on SAP, which is obviously infinitely better than a mainframe, right? There's got to be some single coherent user interface on top of all those existing services. Now, if I look at something like this, when I first started getting into e-commerce about 10 or 15 years ago, composite UIs were a really tough problem, and there were almost zero tools available for us to do this easily. So when I was in my very first e-commerce job, what we would do is just not compose at all. And this is a valid choice. We can say, ooh, this is, the challenge is too great. Let's just not compose things together, and we'll just build these really tall vertical slices that go all the way up to the top. So you may even notice this as you're going through a website. If you keep an eye on the domain and subdomain, you may notice it changing over time. This is built in a time before people could really build these kind of composite applications. And they just threw up their hands and said, forget it. We're just going to build, instead of a singular interface for the end user, we're just going to build multiple applications that have their own delivery and release schedule. And we're going to take that all the way to the top to say they each have their own databases, they each have their own UIs, they each have their own teams, and they're all completely responsible for the entire experience for that one individual vertical. Now, we did have some ability to share things between different services here. In that case, we'd build a content delivery network, or CDN, for just like the most very basic CSS and sometimes a little bit of like fonts and things like that. But for the most part, the only thing that was shared are these really static assets that don't really change over time until the marketing department gets like a windfall of money and they decide to change everything, because how else would they justify their existence? So with this content delivery network, it's okay, but it doesn't really provide any shared behavior or any shared experience between these different applications. And one of the things that we found, and I was actually part of the orders team for this one application we were part of, it was really hard to fake a composite UI with all these disparate applications. The user experience almost always suffers. We don't have some singular coherent user interface that ties everything together seamlessly for the end user. And you know when you're in one of those applications or in one of those user experiences where they haven't tied anything together. Pretty much every single help desk phone operator is a non-composite UI. That is, you are exposed completely bare whatever crazy backend services and departments they have behind the scenes. So something's wrong with your plane ticket. You call service. They say, okay, let me route you over to the reservations department. You get over to reservations. Reservations said, oh, you actually purchased that with airline miles? I have to route you over to the rewards department. Rewards department says, ooh, that was a transfer from another user or from another person. Now I have to go to the transfers department. And so you're completely exposed to every single organizational inefficiency behind the scenes, when really you just wanted to fix the problem with your airline ticket. So although for some of those kind of back-end pieces, I may optimize for not composing pieces together because, I mean, they've already purchased the ticket, so, you know, screw them. But for people that haven't quite entered my revenue stream yet, I may want to actually compose things together to build that really nice end user experience. So supposing we go down this path and we say, okay, now we want to build that nice user interface to compose everything together. We're now presented with a choice. Where are we going to compose these different pieces together, and how are we going to do it? If I look at any one individual request in an application, there are a number of kind of three major players that take part in the request for something and presentation of it to the end user. Each of these presents a choice for me about how to compose pieces together. Now, it's not exactly in tier because this crosses over to user space, but you can, in most part, think about it in terms of there's the application that the user is running. For me, it's typically a browser, but it certainly could be a thick client application, an Electron application, a mobile application. This is the application that is run on the user's side, and this could be one of the places that we compose. We can also compose before that user gets the information on the server side, or we can compose all the way back to the back end into the database. And so for the rest of the time, I'm going to be walking through each of these different areas of composition, walk through some of the techniques we can use to help compose these pieces together, and some of the advantages and disadvantages about each of these specific areas. For any big application I've worked on, whether it's a large e-commerce or even a backend system, I don't really say I would pick one over the other. It really depends on what I'm trying to accomplish with the end user, and then I make the appropriate choices about where to compose based on the different constraints I have, and most importantly, the end user experience I'm trying to achieve. So let's first look at how we can compose at the browser side. I'm going to be using everyone's favorite example for service-oriented architectures, or now microservices, which is going to be Amazon. I just happen to search something randomly, of course, and of course Bieber comes up. He's matured over the years, looks like. So looking at this, this is the experience I want to have. A lot of times I start from wireframes or something a little bit more substantial. The first thing I would need to do when looking at how to compose these pieces together is every single framework has their own way of composing pieces, so I have to first choose what is my front-end technology I'm going to be using to pull these different components together. Each of those front-end frameworks has their own flavor of how to compose pieces together. Angular has the concept of modules. React has the idea of components. Aurelia, anyone use Aurelia here? Yeah, a few of you, okay. I'm sure it's going to be around next year, sure. Uses components as well. And finally, if you're using just some like random noun.js component that hasn't been invented yet, then it's probably going to be called components. For the most part, it's going to be called a component in whatever library you have, except for Angular, which will muddle the definitions and mess things up as they're wont to do. Now, in each of these components, I can always build these components independently of each other. But the problem is, how do I distribute these components to actually package them up and hand them to the front-end team to actually use and be able to be deployed to my end server? Luckily, we have a technology that allows us to do this, and it's known as Webpack. Webpack, which I think is very close to its 3.0 release, is able to bundle up front-end assets into a singular package that can include my backend, or not my backend, but my kind of JavaScript code to handle requests, the information I'm going to be showing on the screen, any sort of styling in CSS that needs to present the information in a certain way, the templates to be able to templatize and show that information, and finally, if there's any interactions that happen, so I click a button, or I click a little drop down, or click a link, there's handlers associated with that to be able to perform some action based on what the user is doing. So I slice up my user interface, start to build more and more of these individual Webpack components, and each of these Webpack components stretches down talking to an API behind the scenes. So I'm building not just a single set of components for everything, there's always some sort of backing service for each of these components that it's going to be talking to. Most of the time, the team that's building the API is also the same team building the individual components. We often call these front-to-back or back-end, front-end services. The idea that I need to stretch my team all the way from when they're presenting the information to the API behind the scenes. I try as much as possible to not have the API team and the front-end team being different people. That's when you start to get in these weird, like, oh, let's develop against a Swagger definition, and then it'll meet in the middle somehow magically. And in reality, it's more like they're way off because we can't actually service that request appropriately. So I try to make as much as possible our teams handle both the back-end service and the front-end component that's servicing that piece. Because at the end, the user shouldn't care these different boundaries. It should just work, and the best way to work is to have everything vertically completely coupled to each other. So with all these different front-end components talking to the individual back-end services, I can start to go back to my user interface and start building these individual components around these different widgets I see in the screen. So I might have the promos widget at the top. The promos team is connected to some marketing team that knows for certain holidays we want to promote specific things up there. That's the banner I really never look at. It's just like, some holidays coming up, buy flowers or cards or something, and I'm like, nah, I'm good, thank you very much. I have a team for the account information. Maybe there's one that just takes care of images. This one is a CD or music, so it's different formats that are could be different based on whatever music I'm looking at. And so I build all these different widgets for all these different components. Now, assuming I can build all these different widgets appropriately, and I have individual service teams that are building each of these widgets, the final piece is to package and deploy my widgets to the final end user and the end application. So in our systems, what we'll typically have is individual service teams packaging up their Webpack components, publishing them to either an internal or externally hosted but still secured NPM repository. And then at build time, our store website is pulling down those Webpack components, deploying them into our front-end application. And then my front-end application, when a request comes in, is going to call the appropriate back-end service behind the scenes. Now, this is where you may start to get into things like API gateways to help manage this communication or manage the security of it. That's perfectly okay. Just make sure you're not using API gateways like the SOA people use those big, heavy brokers. The API gateway should be as small as dumb as possible, and ideally inside one of those service verticals, and not something that tries to compose everything all together. One thing I will not recommend is using an API gateway to be your unit of, or your vehicle of composition. It will just become a mess of business logic and craziness, and that's one of the big reasons why SOA failed. We want to try to avoid that with microservices, because I just can't take another definition of the exact same thing that's like the better way to do it. Nano services or serverless, I can't do it anymore. Now, when you're building these, one of the ways you can tell if you're not getting the boundaries quite right is when you have these cases where you have components talking to each other. When you have components talking to each other in order to perform their business function, that means they're not really that autonomous. The idea behind autonomy is that I should be able to perform my action, my thing that the reason of my existence, without having to rely on any other services. I should just have to talk to my backend service the request, and be done with it. So if you have a lot of communication on the front end of things talking to each other, that's a really good sign that your boundaries are wrong, and you should take another step back and say, maybe my boundaries should be a little bit bigger and not be so perhaps noun-oriented and more capability-oriented. If you have services that are things like order service and product service and user service, those are the nouns of your system. Those don't really describe the business function it's supposed to be. So when I see noun-oriented architectures, that often means they're very chatty because I have to coordinate many services together. So instead, we have things like checkout as a service, which is a specific user flow that the user goes through. That's more rooted in the business side of things, and this is just a symptom of that problem. A lot of communication going on. Now, there are a lot of other details about how to glue these pieces together and governance models as well. Those are going to be very company specific about how you should pull these pieces in. Most of the time, we have a kind of architect team or an enterprise architecture team that doesn't just produce PowerPoints all day long, but they're the ones that are trying to build the pieces of how to pull all these different things together. So they're typically the ones that are defining what it should look like on the NPM package server, what the naming conventions should be, and then actually helping design the shape of those components so they don't have this really chatty problem with poorly designed components. Now, as much as I like to compose on the browser side, that really works well when I have a lot of independent widgets from each other. But it doesn't really work well when I have to compose multiple backend services into a single widget to be presented to the end user. For those kind of services, I find it a little bit better to be using server-side composition as opposed to client-side composition. Client-side composition as well, it only works if you're using a really good front-end framework, and you may not be able to just switch your entire development team over to React or Angular or whatever, nor should you just to be able to do some kind of composition. Now, unfortunately, server-side composition is, I'm going to be honest, it's a little bit messier than client-side. The frameworks that you typically use on your projects almost universally aren't designed for composition. They're really designed to handle a single request and get a single response back in the form of some single HTML document. But how you compose the little HTML pieces together, that's really not what these frameworks are designed to help out with. So sometimes you can leverage some existing kind of extensions in the front end, the back end frameworks. Sometimes you have to invent your own new way of composing things. And so I'll show two ways of doing that on the server-side composition. Now, on server side, we're almost always going to be using model view controller, or controller model view, or controller view model. It's MVC. The letters can be switched independently of each other. And so look at this, and now I have to decide, again, now that I've chosen server-side composition, which one of these three areas I'm going to be using to perform my composition. I can just tell you right now, not in the controller. Controller shouldn't have logic, so either it's on the model side, when I'm building up the model of information on the screen, or it should be on the view side when I'm actually displaying it to the end user. Let's look first at the model side composition. Model side composition in a website like Amazon, I can typically see it in something like an individual product details section of a screen. This is something that's going to be repeated over and over again, and I'm typically doing something like, give me all the product details for this specific product ID or SKU or what have you. And I want to take all those pieces together and pass them to a view to have one single nice widget that everything can come together. In this case, I don't typically have different service teams for individual little snippets on the screen because they're not that autonomous. They can't really live by themselves. They have to be pulled together into one single coherent user interface. If you have teams, for example, that like junk up your styling or mess up their HTML, you really want to have a team responsible for this entire widget to make this thing make sense to the end user and not expose that however it came to be behind the scenes and the service teams behind the covers. So in something like this, what typically happens in an application is I issue a request for some kind of data that says, I need this one, for example, I need some kind of product details for search results. But the product details can come from a lot of different places. And what I like to do is go to all those different places, gather up all the data from all the different people that I'm talking to, and finally get that one single view model that I'm going to be passing through the view to say, I'm done getting all the data, here's the final result. So we can start out with a request that says, I need some sort of product result for this product-specific ID. We'll make those requests to every single backend service that we need to get that information from. Product catalog, the pricing service, the rating service, recommendations, customers who bought this also bought that other thing. And then finally, once all those pieces are done, I have now one single model that I can pass into finally the view to render all those pieces of information. Most of the time, though, I don't like to tie myself to specific objects and types. These systems like this, I want to be as loosely coupled as possible. So most of the time, I'm not tying myself to a type. I'm really tying myself to a request, an HTTP request that says, any of these services that can service this request, please give me your data, and then I will give it and show it on the screen. Now, this is where things can also go really horribly wrong when people are building out these kinds of architectures. I've seen this go so poorly that 9-figure projects have been canceled, like spending over $100 million be canceled because they screwed this up. We want to make sure that these calls to these other services are very fast. We want to be waiting on one of these services to get a response back before we go on to the next one. Or if one of these is down, I don't want to have one of these services that is unresponsive or slow or just completely gone to screw up the rest of the request. So we want to make sure when we're building these things that we're putting some resiliency around each of these calls so that if something goes wrong, we can still go on and service the next request. An application that did this wrong had hundreds of these kind of API calls, and literally if one of them failed or was slow, the entire page broke. That's not really the spot you want to be in. If you want to have autonomy in this overall top-level UI service, it can't be beholden to these lower-level services to be up or available at all times. This is often where you see the Netflix chaos army start to come into play. Well, they'll be able to take out individual services and make sure that the front end can still appropriately render okay. So for example, if recommendation service is down, we just wouldn't show the recommendations and we move on with our day. There's a lot of literature out there about how to handle resiliency in service-oriented architectures. In the .NET C# world, there's a great project called Poly Project, which we can wrap all of our service API calls and some resiliency, like if it fails 3 times in a minute, stop calling the service. Or if it keeps failing, then let's exponentially push out the time because maybe that service is just getting overwhelmed with requests. But I want to have something that says, make this not a single chain of links where one link broken means the entire chain fails. I want to make it more resilient so that if one thing fails, the end user may never even notice that service is out. So this kind of composition model does not exist in ASP.NET, MVC Core, or almost any other framework I've seen out there, Django, Rails, really nothing like that has this kind of like, here's a request and who are all the pieces that can get my information and then show it on the screen. But we can build something similar ourselves. What I'm trying to do is just have a request go through a series of services and says, whoever can service that request, append some new data on. So we can come up with a rather simple interface that just says, I'm a route interceptor, and if I match this individual request context, that could include the URL information, it could include the query string, could include some HTTP headers, so maybe I'm looking at different languages behind the scenes. Then entire request context, tell me if you match or not, and if you do match, then at that point, I'm going to hand you the request context and this view model as a dynamic, which is basically a dictionary of values, and you are going to append your information on top of that individual view model. Now, the reason why I'm using dynamic in C# is because I, again, don't want to couple myself to one individual contract type information. The last thing I want to do is have to worry about versioning and all this sort of junk like that, strong like that. No, just pretend we're a dynamic object, and then we just won't be stupid in the front end and misspell something. And that's about as good as we're going to get. I typically find for these kind of things, we don't really like stomp on top of each other with different property names, because we're all friends. We all go out to beers on Thursdays, so we know we're not going to screw each other up like that. So I find that this sort of like dynamic dictionary sort of access is plenty good enough for most of the scenarios I run into. Now, the idea here is that with this view model appender, each of these different services implements those different view models appenders, and they also look at the controller and action and path information and say, I'm one of those things, so I will go out and call to whatever API behind the scenes, or it could be just content going straight to the database, and appending that information into one final view model that's going to be then finally passed out to the view to be rendered. The view doesn't care where the information came from. The controller doesn't care where it came from. I just know I have a series of view model appenders that can append information to my view model and finally get that one final coherent result to the end user. Magic, allegedly. Now, this is something you have to kind of come up with yourself, of course. There's no framework out there to help make this possible. It's very dependent on the kind of application you're building, the framework you're in, and exactly how you're composing pieces together. So you kind of have to go back to those old patterns books to see what are good design patterns to help enable these kind of architectures. But once you kind of settled on a good approach like this that is not so coupled to any one service, then it makes it really easy to add new kinds of appenders, to append new kinds of data. Those are just new implementations of these things. So that was model-side composition. The next piece for a back-end server-side composition is going to be view-side composition. Now, view-side composition is very similar to what we had in the browser-side composition. We're effectively slicing our screen into individual pieces, but instead of those pieces being composed in the browser, which may not work in every single scenario, we're instead going to compose those on the server side, so it's just one piece of HTML being returned to the end user. Now again, at this point, it's going to very heavily depend on the server-side technology that you have. In this case, if I'm using ASP.NET Core, ASP.NET Core has the concept of a view component. Every single MVC framework has something like this. But these view components in ASP.NET Core are, one, they're a replacement for the old child actions of MVC. But what these do is they encapsulate kind of a mini request on the server side, where the mini request includes some kind of invocation, kind of like a controller action, but hopefully smaller and more lightweight. It encapsulates a model for the individual widget, and finally, some sort of view or template associated with rendering that model. So after I slice up my screen to each of these individual pieces, each of those individual pieces is going to be not just a template to be shown, but it's going to include these view components which encapsulate the entire request there. The good thing about these is they can include their own parameters and business logic. So I have to say, show me the product details for this specific queue or the recommendations for this specific queue. I can pass that parameter through from a sort of top-level layout all the way down to the individual components and have it get that request-specific information from the very top level. Or if there's some kind of custom business logic, which we'll see, that can be encapsulated as well. The very last thing is that this is typically invoked from the view, typically kind of a master page layout, the very top level view that has everything organized together. These are the pieces that are going to invoke those individual components. In MVC Core, the way we can define one of these view components, it's .NET, so of course we're just going to do inheritance. That's what they like to do. I inherit from this view component object. This view component object, in this case showing the stock information, whether it's in stock or not, it can take its own dependency. In this case, I'm taking dependency on an Entity Framework DB context. But of course, it could be whatever you want here. If you need to make a call to an API, if you need to make a call to some other kind of in-memory service, if you make a call to maybe a Redis provider for cache information, it's really completely encapsulated inside this component about how to get the information is going to be showing on the screen. So in this case, I'm going to go to the DB context, get a list of the stock items that match that individual SKU, and then finally display that view on the last line there. And on the view side, I'm only trying to show that one individual widget on the screen. So the HTML here is just that one single widget. Almost always I have something that can identify that one widget. So in this case, I have an outer div that says this is the availability div. And of course, there's going to be some junk for CSS classes. And then inside of there, I'm going to be displaying the stock message to say whether this item is in stock or not. The model CSS class for in stock is going to be green, and for not in stock, it might be red. So I also have the controller, the view component, tell me exactly how to display this information on the screen. Next, I need to invoke this component from inside the outer layout. So this is going to be the outer layout code that is trying to pull all these different components together into one single coherent user interface. And it can use this component invoke async. Ugly way of doing things. There's a better way in ASP.NET Core 1.1, which I can just use this tag helper to say, show me the stock info for this individual SKU. In this kind of compositional model, it is the outermost layout or template that is defining exactly which widgets are going to be showing on the screen and exactly how to call into those widgets. The widgets themselves, most of the time, I'm going to be using something like another package manager to distribute these, probably NuGet for .NET, in which I would build my package behind the scenes, and then I'll distribute that component out to the front end. So that whenever the front end runs, it's going to get whatever the latest version of my component is, and that's going to be what's getting plugged into here as well. We do have to worry about component versioning as well, so I really don't want to break the contract of what these parameters look like. But for those kind of things, it's not. I don't find those pieces really break over time. If I want to show stock information for a SKU, I'm really not adding new pieces of information. It's just show me the thing for the SKU, and then it's done. So I try not to worry about too much like versioning sort of things when it comes to calling into these pieces, because I just don't find they change much over time. Okay, so we did browser-based composition. We did server-side composition, both in terms of building up a single model for a complex widget, as well as view-side composition, where I'm pulling multiple widgets together on a single page. The very last compositional option that almost everyone ignores is going to be database-side composition. Now, I'm not talking about again, this is where people can get in trouble, because they'll use compositional tools to help compose multiple API calls together. This is really talking about a situation where I want to pull multiple pieces of information from the back end into some coherent database structure that is tailor-made for whatever kind of request I have on the front end. Now, a great example of that is going to be a search page. In this case, I was again looking for Justin Bieber CDs, and I wanted to just show me all the Justin Bieber CDs there are that's out there. And it looks like there's 352 of them, if you can believe that. And if I'm looking at trying to service this request, I don't want to put the burden on all of my different service teams to say, hey, not only do you have to be experts in this kind of technology and this kind of service and this kind of capability that you're doing for the business, you also have to become search experts, because I'm going to query into you and try to query results out of your system. This is another place I see a lot of service-oriented architectures really fall down, is that they try to push the burden of something as complicated as search onto all those different services. And not just search as well, so things like product recommendations, those customers who bought this item also bought, there are databases that are designed to answer that kind of question. And if I try to push that kind of question that's really hard to answer for some certain databases, like has anyone tried to build a recommendation engine in SQL Server? And live to tell the tale? Yeah, it's not fun at all, because it's not really built to make a lot of these different connections between things. But for something like this, there's really great tools out there already existing and open source and free. This one, for example, we went with Elasticsearch, which that is their funny looking logo. Elasticsearch, the way it works is you have, it's basically a fancy key value store, document database, but it's still key value, that I build up a structure of each of these individual things I'm trying to search on. So all the information you're seeing in this widget that you can search upon has to go into this one single document. And then on top of that, I put on top of that different indexes that allow me to search over those individual documents. So for this one, I can kind of imagine looking at each individual search result, there's some kind of document that represents that information I'm going to be showing on that screen and that I can search on as well. I have to put all this information into the search database, again, because that's the primary access I'm going to be using here. Now, if I look at this and look at the service boundaries, different services own each of these different pieces of information. I have the catalog service that owns the kind of master SKU ID and product ID, as well as some basic product information. There's some sort of image catalog that owns the content delivery network URLs. So this one, for example, I can just go to Bieber underscore shirtless to find that shirtless Bieber image. It's not actually true, but it'd be nice if it was. The different formats for the music, that's coming from somewhere else because, again, not every single piece of content has every single piece of music, and it can change fairly frequently. So if suddenly Justin Bieber revoked his rights for streaming for some unknown reason, then that would need to come away from this result. And finally, I have some sort of like review detail information. So like the number of stars up there, and then how many people have reviewed it. Again, I want to have that right in the results. Now, this is not all the information from all these different services. I'm very selective about what exactly information I want to include in my search database, because I don't want to just pollute it with the superset of every single piece of data ever collected across all my different services. I'm being very purposeful about how I'm building out this search document. But each of these different pieces of data does not come from the search service. This is where the DBAs kind of come in. They're like, wait a second. Something's wrong. I smell data duplication. We have duplicate data. I've got that same SKU in my product database in that front-end search service. I've got the same URL in my content delivery CRM thing behind the scenes. It's now being copied over to the front end. And how are we going to manage all this crazy amount of duplicate data? This is also where I see a lot of people try somewhat abandon service-oriented architectural principles because they say, right, we're going to build services, but we can't duplicate data because we have to own that information. The services owning the information does not necessarily mean that it's physically inside their boundary. There was a great paper from Pat Helland. This is one of his more like family-friendly names of talks that he has. He has some not so family-friendly ones, but this one's called Immutability Changes Everything. Now, Pat Helland was an engineer at Microsoft and some other database companies before that who literally designed the transaction system inside a SQL server. He went to go work for Amazon and Salesforce and said, you can't actually build these systems with one single master database behind the scenes. You have to give up something. In this case, we're giving up owning physically all of the data in your system. So what happens if I copy that data somewhere else? When is that okay? Well, it's okay if the other services that are receiving the information are not allowed to change it. That is, it's immutable. I tell them when things have changed, and they just have to take that information and store it however they want to. And this is exactly our search service. Search does have some ownership of things. It owns the shape of the data, how it should be structured inside the search database. It owns the SLA of the response, how quickly it comes back, as well as how relevant that information is to the end user. If the search information and results aren't relevant and don't make any sense to the end user, well then no one's going to use search anymore. But for me these days, I almost don't even use Google or Bing or DuckDuckGo or whatever. If I know something's going to be on a specific website like Stack Overflow or Amazon, I go to that website and do the search because the searches have become so good. So the search service owning all of these pieces, but doesn't actually own any of the data behind the scenes. So the entire document that we saw, none of that data is actually generated by the search service. There may be a relevancy piece down at the bottom that I clipped out, but as far as the actual product information, search service doesn't own any of that stuff. Now, what we want to have happen is, in order for the search service to be, at any way possible, to be used and built, it needs to make sure that the search data is there at the time in which I'm performing my search. So how do we get all these backend pieces to push that information back up? This is where we start to build these backend integration components. There's a lot of different names for these things. I call them denormalizers because they're taking kind of normalized data from other services and squashing them down into one single document for my document database, search database in the front end. But this is a completely out-of-band process that's happening behind the scenes and not at all visible to the end user. I'm pulling in all these different pieces of data so that when the front-end user actually performs that search, they're not going to any of these back-end services. They're just querying to that one search database and getting a result back and calling it a day. Now, for a lot of companies I work with, it's not as easy as drawing a PowerPoint and like pointing an arrow in one direction. They actually have to kind of design how these pieces are going to come together. And so in that case, you kind of have to go back to some of these old integration books to say, how do we connect these backend services together? So depending on the service, I might use different API patterns. So for example, I could look at the catalog service and say, well, there's just a known number of SKUs in the system. So why don't I just call that API once a day, do a once a day update, and pull that data into my search database? And just for however many millions of things or million of things there are out there, just once a day, get the latest results and call it a day. Now, when I'm designing these interactions and these integrations, something I have to keep in mind is how often does that information change in the back end, and how quickly from that information in the back end have to make it up into effectively my cache on the front end. With all the other composition models we saw, that can all be like basically live data. But for something like this, I have to make a choice about how soon does that information need to be updated based on back-end changes. And the truth of the matter is not that often, because the users don't care. Like if Justin Bieber decided to change his CD name to something else, like how quickly is he going to make that decision? Well, maybe Bieber wouldn't be changing his mind about that all the time. I don't know. But for something else, someone who doesn't have so many mind changes, then I don't have to worry about that information making it to the front end so very quickly. It could wait a day, because if there's really no business loss in that day of information being out of date, then who cares? Now, I even might have some cases where information has already been sort of pre-composed for me. So in this case, there is a database of images and SKUs, but if I go look at my API calls, it turns out that information was already being returned with me with a catalog, so I could just say, we don't have to call that service at all. We'll just sever the connection and move on to the next one. We may have some that are more kind of old style services in the back end. Maybe these are the AS400 style services in the back end. And for some of these, I may have to choose an integration style I might not like, but I'll have to live with. So in this case, for the formats, it's something that almost never changes, but could, in this case, maybe it serves a lot of other internal clients. And so we're able to use an existing integration method. In this case, it's just a file being dropped on a share drive somewhere. And so we'll just consume that file once a day to suck in all the different formats for all the different SKUs. Again, it's not the prettiest kind of code to write, but sometimes I just have to work with whatever is already existing there. Now, sometimes I have to react more quickly to changes. And in this case, I want to use a more reactive integration mode. In this case, messaging is a great way for us to be able to react to those changes. So in this case, I have a review database that's built on top of SQL Server for whatever reason. And I want to react to that information quickly because I want to make sure the stars that show up are pretty frequently updated. Because if I go add a review, I kind of expect it to show up somewhat quickly. So in those cases, I want to have that information being pumped out, shown very quickly to the end user. In this one, I may not have any existing integration possibilities with me. So this one, I may have to buy the DBA a bottle of nice whiskey, take them out, and say, hey, can you go ahead and add some triggers for me that can generate messages? And then those messages I'll go ahead and consume on my side. And just don't tell anyone, please, because we don't want the DBA police to come on us here. So as people make changes in the review side, it generates new messages that I consume on the search side to update the same results and reviews on my side. So when someone does something like show me a product with more than 4 stars, they don't get a result that says 3.5 stars because it was just reviewed or something. So based on all these different compositional options with browser side, server side, and database side, again, none of these are going to be a completely across-the-board decision for you. You're really going to have to look at how your application is built together and what's the most important thing for the end user. But I would say for myself, the first thing my very first choice is just don't compose until it's absolutely necessary. Composition is a very hard problem to have. It's a very difficult challenge. There's a lot of tools today to make your life easier in terms of packaging and distribution, but it's still a hard thing to do. So you want to really make sure you have those boundaries right and the user experience right before you partake in this challenge. By the way, when I say it's a challenge, it doesn't mean we should try it. It should mean we should think carefully about it and not just dive in head first. whatever compositional model I choose, whether it's browser side, server side, database side, whatever that is, I'm going to base that decision on what's best for the end user experience. Because again, the whole reason why we're having to do this is have that last mile, show the user this final user interface. And we have to be going from that design backwards to see what are the right ways we can pull these different pieces together. Now, again, we're building distributed systems. So we want to make sure we're not treating the fallacies of distributed computing as truths. I see people screw these apps up when they just assume latency is 0, services are always up, things like that. So treat those fallacies as if they will always happen, which is what I typically do. If I'm going to call a server, I always ask myself, what happens when this goes down? Not if, or not just ignore it altogether. And the final piece I notice, especially for something like the search service, these front-end UI services that start out as just kind of generic pulling pieces together can very often graduate into their own service boundary unto their own that fulfills a specific business purpose. So with that, thank you very much. That was Compositional UIs, the Microservices Last Mile. I'll be right here for questions. Otherwise, have a great rest of the conference. Thank you.